To graph polynomials, we need to know lots of different things. But one of the things we need to know is the end behavior of a polynomial. And end behavior of a polynomial, that refers to what the polynomial is doing as x approaches infinity and as x approaches negative infinity. Okay, we want to know if our function, if the y values are getting larger or if they're getting smaller. And so this is all determined by two things, the leading coefficient and the degree. Okay, so the first thing you're going to look at is the leading coefficient of the polynomial. And if the leading coefficient is positive, then we're going to be, we know that y approaches infinity as x approaches infinity. Now what this is saying, I'm just going to draw a quick sketch up here, all right? So as x goes to infinity, that means we're moving to the right of the graph. And as we're moving to the right, if y is approaching infinity, that means that we're going upward like this. If the leading coefficient is negative, then y approaches negative infinity as x approaches infinity. So this would be the case instead where we're going down. Okay, and so this is here y approaches negative infinity as x approaches infinity. And this one up here is y approaches infinity as x approaches infinity. Okay. You'll notice that this x approaches infinity is the same for both of these. That's just saying essentially on the right side of the graph. Okay, and then this tells us if we're going up or if we're going down, and that all depends on the sign of the leading coefficient. All right, positive means it goes going up on the right, and negative means it's going down on the right. The next thing we'll look at is the degree. And here we'd care if the degree is even or if it's odd. If the degree of the polynomial is even, then y has the same behavior for x approaches negative infinity and x approaches positive infinity. That means if I know that my right side is going up and I have an even degree, the left side will also be going up. Okay, that would be like that over here as well. We see that in, for example, y equals x squared with an even degree, because the squared is an exponent of 2, which is even. We know both sides do the same thing. If the degree is odd, then y has different behavior for x approaches negative infinity and x approaches positive infinity. So this is saying on the left side of the graph, it will be different than on the right. So if we know the right side is going up and we have an odd degree, we would know the left side is going down. So there's a lot of things going on here, and it'll help to see some examples. But if you just know the leading coefficient and degree, that can tell you quite a bit about what the graph is going to do on both sides. And kind of a quick check on your work is this nice fact here. The graph of a polynomial has the same end behavior as the graph of the leading term. Okay, so this is really quite useful because we should know what the power functions look like, what those graphs look like. So, for example, if I had a function, say p of x equals, and I'll just be real quick here, maybe negative 3x to the 4th plus 2x to the 3 minus 1, all right? This graph right here, well, what this tells me is that I can look at just this first, this leading term, and think about what the graph of that would do. And well, I know that x to the 4th, that kind of looks like a parabola, okay? And then I've got a negative 3, and that's, well, a leading coefficient. A negative out in front of the function flips it down, and so that would flip it down, and then I'd end up having something like this. All right, and then what this tells me is that my end behavior is the same. So the graph of this function would be going down on the left and down on the right. Now what happens in between, we're not really sure. Okay, this is negative 3x to the 4th. We don't really know what this stuff here is going to do to change it. And I want to kind of show you just a little graphic of this happening. So here's our function, and we're going to go ahead and just graph it and see that happen. Okay, you see here that on the left it goes down, and on the right it goes down. And in between you see, oh, there's a little bump here. Okay, it's kind of a little different. It's not just like a perfect parabola, but the end behavior is the same.